Hello everyone, welcome to Practical GCP. Today I'll talk about serverless distributed processing with BigFrames, which is a new feature announced very recently and still in preview. So as usual, I'll throw a problem here and then to kind of discuss how we're doing things at the moment for distributed processing and transformations, and especially some of these more complex use cases. And I'll cover what is BigFrame, how does it work, and why should we even care. And I will show a demo in action on how BigFrame can be utilized to do data processing in this particular case. So finally, I'll go through the pros and cons and plus some ideas. Let's crack on. Okay, so what problem are we trying to solve? Well, it's not necessarily a problem, but it's more of a complexity. So assume you get a task at hand, right? Which is to enrich data, filter out, or do some really complex things that require that are based on some complex rules, right? And do a bit of more transformation, which could be some sort of SQL workload. And then I want to encrypt some sensitive data, right? And then finally, I want to export the data either as kind of a batch workload into GCS for third party to probably get hold of this data. Or I might actually want this data to be connected to some downstream software services via a message queue, which I might send it to PubSub. So you can see there's quite a few things going on. And then you could do this based on, you can do a bit of things in dbt, you can do a bit of things in BigQuery, you can orchestrate some stuff in Airflow. But the thing is, usually this stuff can get quite complex. So for majority of use cases I see, that most would probably choose to use Airflow to orchestrate and run Dataflow jobs, where Dataflow actually does majority of the processing and handle the complexity and also sending the data to the downstream systems. Okay, there's probably a few issues in here. So one is Beam, Apache Beam, which is what runs on Dataflow. It's quite a steep learning curve from my experience. There's quite a, I would say, small group of people kind of really specialize in this area, and I can actually deploy and operate in Dataflow to run a big pipeline. And also this is a single big distribution, right? So in order to deploy this, first of all, you need CI/CD, packaging the containers, and all of this stuff to just run in the Dataflow container, right? So, and then this whole thing is typically a big distribution with lots of dependencies that you have to install. And finally, the deployment isn't straightforward. As I mentioned, the packaging, the kind of even debugging to try to make it run isn't exactly straightforward. I did create a video on how you can actually package your code, your Beam code, into a container that runs on Dataflow. You can see it's not exactly the most straightforward thing. Okay, so this is where BigFrames could potentially offer an alternative that is a lot simpler and more friendly to a larger group of people. So Google's definition on BigFrame is Google's data frames, which is BigFrames, provides a Pythonic data frame that machine learning, ML, API powered by the BigQuery engine. So it has two libraries. One is the Pandas one is the ML one. It's an open source package which you can install, and that's called BigFrames, right? It's still in beta. I think it's currently 0.10, the version. So my definition on this is it's easy to learn, completely serverless, distributed compute orchestration framework for batch processing. So I'll explain in a minute why I feel this is the way it is. Obviously, all of these use cases are at the advanced side of things. You're always going to plug it into ML, right, to do advanced analytics and decision making. But there's always, before you can actually do any sort of machine learning, you need typically quite complex data processing, transformations, decision trees, all of this stuff before you can actually even use that data. So look, So this is how, in my opinion, you could design a pipeline, right? By utilizing BigFrames in this particular way. So let's have a look at this from the left to right. So first of all, you'd have some data models, right? This could have been done by your data modeling team, is already relatively good quality. But in order to actually do something that is actually more advanced, to unlock more use cases and values, you typically have to do certain things such as the enrichment, right? So in this case, the enrichment, you probably have the first box in there, which could be just some SQL joins. So keep in mind, one of the very important thing is, as mentioned in the previous slide, is it says Pandas in this BigFrames provides a Pandas compatible API for analytics. But there's one more important detail in here that is very important. All of the compatible Pandas API, when you run it on BigFrames, it runs on BigQuery or via BigQuery to use cloud functions. So I'll explain a bit what this means. In this case, you have a SQL join, right? This enrichment that you do. So because it's quite easy, and this is join, and then this thing you can actually just run on the BigQuery engine. So what it will do is map the Python API of Pandas to actually a SQL job, right? A BigQuery job to run on the BigQuery engine. So it does actually run locally. So this is very important, which means you can run stuff at scale. Next, when we want to do something complicated, right? So decision-making, filtering, all of these things is not exactly easy to do in SQL. What you can do in here is remote functions. So this is something, I have another video, I talked about this before, is you don't actually run this on BigQuery, but you can actually have a SQL interface, which is basically just a function that you can call via SQL. And then this will actually delegate the execution to the Cloud Function version 2 or Cloud Run. So both of them are compatible, but Cloud Function version 2 actually runs on Cloud Run as well. So this, your decision making, now you can delegate to, you can call it like a microservice. So every single row, right, or column, when you send via the Pandas API, it will delegate to the remote function, and then via HTTPS calls into Cloud Function to give you this exponential scale of how this serverless stack can actually basically do some transformations and return a result to you, so you can actually continue in your data frames. And then I suddenly want to say, I want to do some encryption, right? How am I going to encrypt? Because I need some customized libraries, right? Or some other things that I need to run that has nothing to do with the previous step. This doesn't make a lot of sense to mix it up, right? So in this case, I create a different container, and in here, I would have the necessary dependency required to do my encryption, to get rid of the sensitive data I have in there. All of these via the Pandas interface, right? And finally, I want to probably save the data frame as files into cloud storage. Again, in this case, the actual computation of exporting the data into cloud storage runs on BigQuery. Or I can use the asynchronous send to basically do all of this in a single process and send that into the PubSub message queue for further downstream processing. The whole thing can be deployed onto a single Cloud Run job that is triggered on a cron via Cloud Scheduler. So you might think, oh, Jesus, this actually looks a lot more complex than just doing a Dataflow job. But not really. Let me break this down for you. If you look at this, there's a few important points in there, right? So I'll show you the code in a second, but number one, all the Pandas execution runs on BigQuery, right? It doesn't mean you have to deploy anything. You run the Pandas code just like what I said before, because it's a compatible API runs on BigFrames. That's it. Number two, non-SQL workload will run via remote functions. So those ones, you don't have to do a lot. I'll show you there's something quite dynamic going on here. I think there's a huge potential if some improvements are made in the coming month. So the non-SQL workload, it will run by remote functions and delegate it to the Cloud Function or Cloud Run jobs. Number 3, so remote functions can be reused or deployed and destroyed dynamically. So those are the things I'll spend a bit of time talking about in the demo. Number 4, the whole stack can be deployed on a Cloud Run job. You see here, this whole box here in the middle, you can just run the whole thing on a Cloud Run job. You don't need things like Composer, Airflow, Spark, or any kind of other stuff. You run the whole thing on a Cloud Run job because this thing doesn't do much. It delegates a lot of the execution details, the distributed computing stuff, the complex where extra libraries needed into other services. And finally, the modular execution makes it much easier to debug. See each part of this, it maps it on the other side. It gives you a BigQuery job ID. You can see exactly what it's doing in there, right? And this one, where it delegates into the cloud functions, you can see exactly what it's doing in the cloud function logs on how it's actually transforming your data. So all of these are modules and independent kind of components, which allow you to orchestrate this whole end-to-end journey of your pipelines into a much easier stack and a much easier to manage. Okay, let's see some stuff in action. So first of all, as usual, I've published this whole thing into a repository. There's a few considerations in there. I'm actually using the London bicycle hire dataset. I'll show you in a second what it looks like, and I've actually done some tidy up when I put it in. So there's a few other design considerations. You can read these afterwards, and I'll put a few more updates based on at the end of this video. And there's also some limitations, but we'll come back to that. But first of all, let's have a look at the actual dataset, right? So this is the dataset I'm using. I've done a bit of casting and converting, so you see something like this, right? This is the dataset that we're dealing with. So you've got the start date and end date for based on each station, right? This is the excuse me. This is the station you pick up your bike, right? And then this is the day of the week you're actually riding that bike. This is the start station's location, which is the address, and then the duration is how long you've actually borrowed the bike. And this is the number of transactions, number of people actually fit into this pattern. So this is basically the dataset. This dataset is quite reasonably sized, right? So we have about 230,000 records in it, right? So this is not just the 10 records, 20 records. It's actually got quite a bit of size in there. And so what we're doing here, if you look at the main.py, is a number of things, right? So some of these comments you need to kind of keep in mind or cover that in the pros and cons. So what we're doing here is, if we start from here, right, line 55, we're running this query we just saw, right? This is the query we run, and then we pull the 230,000 records from BigQuery. And then what happens is I will map, right? Look at this first one. I'll map the day of the week into the actual Monday to Sunday, right? I'll do this based on a single map. This is very interesting. I'll show you in a second when I execute it. So this actually runs on BigQuery. It doesn't need remote functions because it's a very simple map. It can be converted into a SQL query. Here, the next thing is I'm actually using a mapped duration function. So in this particular case, you can see the map duration function based on the different ranges, under 2 hours, 2 to 4 hours, 4 to 6 hours, blah, blah, blah. So those ones is more complex, right? It can't run this on BigQuery directly. So this is where it's delegated into the remote function. This annotation here is giving you a way to create a remote function on Cloud Function version 2 dynamically. So all you have to specify is the name of, well, you don't even need the name for the function. The name of the function is inferred from the function itself here. You need to say the BigQuery connection you want to use. So this is where it kind of triggers the remote functions. to link to the remote functions. Do you want to reuse it? This is interesting because if you put reuse on it, if you deploy it once, it will reuse it. But there's some issues in this. We'll talk about it later. The input, output, if you want to install any packages, which later on we'll have another one to look at. Okay, next. This will map the duration into those ranges, right? So then we have better categorized data to look at. Followed by that, one thing I want to do is, let's assume I don't really want people to know the start station name, the actual name of it. I just want to know which categories actually goes in, but I want to encrypt the data. So it might not be very applicable in here, but imagine if you're actually dealing with sensitive data, this could become very handy. And this map is a function, again, a remote function, to allow us to do the encryption. So if you look at this thing, it's slightly different here. I take a bunch of strings, and then the package, I've installed something specifically for encryption in here. So then this one will actually deal with the encryption. So moving on, and finally, I'm actually just doing a little bit of aggregation. So again, keep in mind, all of the Panda data frame stuff that used in the BigFrames will be executed on off the actual Cloud Run job, right? So this is running on BigQuery, this is running on BigQuery. So all the aggregation here, again, is running at scale. So I'm then going to print out what happens at the end. There's some code in the bottom which might be useful to you as well. So by the way, this whole example is something I've learned from a Google example, which has a link at the bottom of the repository. So this is the one thing I've actually taken from there as well. So if you don't, this can be very useful in development, right? If you don't want to keep the cloud functions and the remote functions after each run, you want to just keep modifying and doing new things, you can actually do a cleanup at the end of it, right? So you can actually remove them, so it's all clean after it's done. However, keep in mind if the code breaks at this stage, so you won't actually know where it is. So there's some, in order to run this thing on production, you need to really think about, how do you ensure this will actually get cleaned up, right? Because it might not if your code stops running at line 105. Okay, let's have a look at a demo. This is the ID, the same code, everything's in here. What I'll do is I will run the code, right? So you can see what is going to happen. You see, what's interesting here is because I've set to reuse the BigFrames, and it knows the remote function and the cloud function both exist. But look at this. This is where it gets interesting. So the first bit of processing, right, is actually done on BigQuery. So one thing, let's see, right? If you go up and into the query history, right? Look at the query history here. So if you do a refresh, you can actually see it's doing executions here. You see? So these, you can actually debug quite easily. So the first part, I can't remember which ID it was, but earlier when I look at it, oh yeah, this is the one, right? You can see this one has mapped the columns into, Monday, Friday, Tuesday, Wednesday, whatever. So this is actually mapped into the SQL, right? And then the rest, when it's executing other things, you can see it's actually using remote functions. If you go back here, you can see in the processing, and some of these have triggered the remote function, and finally it's given us some results. So the first result is this aggregation bits, right? After it's done the work, so it's the top 5 by day of the week. So this actually aggregated and sorted based on Thursday is the one that is the, most of the people using the bikes, and then most people borrow it for between 8 to 24 hours. That's interesting. And then the number of transactions is this, right? And then the second one, it did the encryption part. So you can see the transactions based on the encryption part, which is the addresses, and is relatively low. But this one, you can see, it has been encrypted. So you can't say exactly which address this is. And that's the end of the execution. As you can see, if you look at the in BigQuery, on BigFrames, so I was running this in EU, right? if I just refresh the content, there's 3 functions in there. I'll explain why there's 3 in a second. But that's the routines, which are the remote functions. You can see these are actually pointed to the cloud function jobs, right? And in cloud functions, if I refresh this, you can see that these have been executed. If I look at these ones, you can see the spikes, right? So this spike has an instance count of almost 30, right? Close to 30, but it was very, very efficient for processing 260,000. Because one thing you have to remember is the way remote function works is not just sending records to the container one by one. It actually sends a batch of 1000 by default. So you can actually utilize the processes within those containers as well, in those either cloud run job or cloud function, to give you much better throughput, right? Rather than just sending every request one by one. Okay, that's the end of the execution. But obviously, if you don't set this to true, and every time it will create a new cloud function, which will take a lot longer, a couple of minutes, and then you have it up and running. Also, there's 2 lines of code are left in here. Is if you have already deployed your remote function, right, which could have been a separate process where when you run this on production, you could actually retrieve it based on the ID. So this means you don't have to create at all. You can just keep reusing it, and you can keep the deployment process separate. But in my opinion, I really like the way to dynamically create this. However, there's some issues and we can't easily manage this. One of the things in here is, you see the thing I showed you, there's 3 things, is if you make a change to any of these functions, right, the way it tracks it is to just track if the function has been changed. If the content has been changed, it will just create a new one, right? But it won't destroy the old one unless you tell every time it runs, it will destroy it. So it's rather hard to manage the dynamics creation, but I think there's really ways you can actually do that. That shouldn't make it that difficult. I just want to show you this, right? So this is one of the limitations in there as we are on this point, is that if you look at this code, all of the cloud function service configurations is hard-coded in there. I really don't understand why this is the case, because this configuration, if you allow the dynamic function to actually track and then passing it through, it will be a lot easier to, for you to track, which function you want to give and call it, right? And then you say if the function is the same, then and this change has been detected, you're just going to update the function instead of redeploying it and deploying a new one, which loses track. So it's just some of these things. I think with these little improvements, this can be so much useful, and you might be able to manage the whole thing in the Python code, and then without actually trying to deploy all of the separate things. So this can be a very interesting thing that we can actually do. Okay, so that's, I believe, the end of the demo. Let's go back to pros and cons and some ideas. Okay, BigFrames, in my opinion, is actually a very powerful thing, can actually orchestrate complex transformations using BigQuery and remote functions. And I believe the end-to-end in this case, right? So especially with the dynamic ways to create this thing, it can make the entire thing, very serverless field. You don't really have much, compared to deploying a Dataflow job or running Airflow clusters with all of these other things. This is actually really simple stack and is yet so powerful and modular. So the dynamic creation of remote functions, it really enables the faster development cycle, I think. So you can actually, if you change something, you will redeploy. It all happens within your laptop or on the cloud. So, and some things that I don't really like, and you really cannot configure the dynamically created remote functions. You can't configure the name of the function. You can't configure the even the ingress rules, because the ingress rules, as the third point here, is public, and you can't make it private. And you don't need a public endpoint to communicate between remote functions on the BigQuery side and the Cloud Run or Cloud Function jobs. So this is always kind of seems like the examples or the default settings is just kind of leave the network side wide open, which isn't great for the enterprise clients. So, and then you have this it doesn't have a way to easily maintain the dynamically created remote functions. So those are the things I was referring to. How do you manage the if you change the function, right? If you change the function from one version to another, how do you retain, clean up the previous ones and just keep the new ones? So I think a lot of these would kind of come back to the first point, is to allow more granular control with which remote functions and which Cloud Run endpoints to create. Then it will be a lot easier, for you can potentially manage everything in the same place with BigFrames. There's some ideas I've got, and I think you probably already know some of these, but I think some of these are common sense. But I think it's important to mention these as kind of interesting ideas. So data scientists use Jupyter notebooks very, very commonly, and then they use Pandas as their bread and butter every day, right? So this really allows to have interactive development at scale at Jupyter notebooks, because right now people might need very powerful laptops or some remote machines to do a lot of this stuff, right? But instead, if you delegate majority of your workload or all of your workload into BigQuery or remote functions with dynamic creation of the functions enabled, then all you need is a very lightweight thing. It doesn't actually need to do much, right? And then I think that's super powerful. And keep in mind the Pandas data frame is compatible with the BigFrames APIs. So which means if you actually do most of that and trial and error in discovery, statistical analysis, and then you swap the whole thing into BigFrame, it will just run, right, on BigQuery and remote functions instead. So that's actually quite a seamless transition from experimentation into production-ready workload. And this two Pandas thing, and that's also interesting too, because especially in data processing, not everything requires a remote function. If you actually convert your data frame to your local area where you probably don't have a lot of data left after the majority of the heavy transformations are finished, then you can turn into a Panda data frame and then do the lightweight processing on the Cloud Run job, right? And then finally, it always connects to ML workload, right? The machine learning development, maybe 80% are data processing, analysis, statistical, computation, all of this stuff. And then, but it also connects to ML workload. I've not explored the .ml library in there yet, but this will get you to a stage that you can actually plug in whatever you need into the ML workload. So, okay, hopefully this has been interesting and useful to you. And this is the end of the video, and I'll see you next time.